Ever wondered what Docker packages are? Well, you're in for a treat. Docker is a popular open-source platform used by developers to automate the deployment, scaling, and management of applications. It's a tool designed to make it easier to create, deploy, and run applications by using containers. Now, containers allow a developer to package up an application with all of the parts it needs, like libraries and other dependencies, and ship it all out as one neat package. This means the application will run on any other Linux machine regardless of any customized settings that machine might have, leading to smoother operations. Docker packages are these containers, but with all the dependencies and information needed to run an application. They're like a box filled with everything your application needs to run, all nicely packed and ready to go. Now that you have a basic understanding of Docker packages, let's delve deeper into how they work. Ready to discover how Docker packages operate? Let's dive in. In the realm of Docker, packages are often referred to as Docker images. Think of these images as blueprints, snapshots of a Docker container at a particular instant. They contain everything needed to run an application: the code, runtime, libraries, environment variables, and config files. Now, you may be wondering, how does Docker create these images? This is where Docker files come into play. Docker files are text documents that contain all the instructions to assemble a Docker image. They are like a recipe, providing a list of ingredients and step-by-step instructions to create these Docker images. Let's imagine you're creating a cake. Your Docker file would list all the ingredients you need: eggs, flour, sugar, and so on. Then it would tell you the order to mix these ingredients, how long to bake the cake, and at what temperature. Similarly, Docker files outline the base image to use, the software packages to install, the ports to open, and the environment variables to set. Once your Docker file is ready, Docker uses it to build an image. This process is much like baking your cake. Docker reads the Docker file, executes the instructions, and voila! You have your Docker image ready to be run anywhere Docker is installed. Now, these Docker images are used to create Docker containers. Remember our cake analogy? If Docker images are the recipe and the baked cake, Docker containers are like serving a slice of that cake. Each container runs an instance of the image, isolated and secure, yet lightweight and fast. The beauty of Docker lies in its portability. Once a Docker image is created, it can be shared and run across different platforms, ensuring consistency in the application's behavior. This makes deploying and scaling applications a breeze. With the knowledge of how Docker packages work, you can now understand how to create and use them. Onward to exploring how to create your own Docker packages. Ever wondered how to create Docker packages? Let's get into it. First off, we need to write a Docker file. Think of a Docker file as a list of instructions that tell Docker how to build an image. The Docker file is written in a simple text file, and it's like a blueprint for your application. Each line in the Docker file represents an instruction that Docker will execute when it builds the image. For example, a Docker file might start with a line that says, "From Ubuntu, latest." This tells Docker to use the latest version of Ubuntu as the base image for your application. Next, we have to build an image from the Docker file. This is where Docker takes all the instructions in the Docker file and executes them. To do this, we use the docker build command. For example, if your Docker file is in the current directory, you might run docker build tmyapplatest. This tells Docker to build an image using the Docker file in the current directory and to tag the image with the name myapp and the version latest. Finally, once we've built our image, we can run it as a container. To do this, we use the docker run command. For example, you might run docker run dp8080 8080 myapplatest. This tells Docker to run the myapp image as a container in detached mode, and to map port 8080 on the host to port 8080 on the container. And there you have it. You've just created a Docker package. You've written a Docker file, built an image from it, and run that image as a container. You're officially a Docker pro. But wait, there's more. Creating Docker packages is just the beginning. The real magic happens when you start using these packages in your real-world applications. Congratulations, you can now create Docker packages. But how do you use them in real-world applications? How can Docker packages be used in real-world applications? Let's find out. Docker packages offer a unique approach to application deployment. By packaging an application and its dependencies into a single unit, Docker ensures that the application works seamlessly in any environment. This mitigates the common issue of "it works on my machine" syndrome, making Docker packages a favorite among developers. Furthermore, Docker packages promote the use of microservices architecture. This design principle allows applications to be broken down into smaller, independent components, each running in its own Docker container. This not only enhances the scalability of applications, but also improves fault isolation. If one microservice fails, it doesn't bring the whole system down. Moreover, Docker packages enable continuous integration and continuous deployment, thereby streamlining the development process. They allow developers to push updates and modifications without disrupting the user experience. Docker packages, as you can see, are a powerful tool for modern software development. Let's recap on the key points about Docker packages. These are essentially encapsulated applications, neatly bundled up with all their dependencies. This makes them highly portable, consistent, and easy to deploy across different environments. How do they work, you ask? Well, Docker packages rely on a layered file system. Each layer represents a set of changes, with the final layer being the writable one. This structure allows for efficient sharing and storage of resources. Creating Docker packages involves writing a Docker file, which is a script that automates the creation process. It's like a recipe for your application, detailing all the necessary ingredients and steps. Once created, Docker packages can be used in a myriad of ways. They help streamline the development process, simplify software distribution, and facilitate the deployment and scaling of applications. Remember, mastering Docker packages opens up a world of possibilities in your software development journey. Keep exploring.